Okay, today's lesson is A73. It's graphing sequences. What's our objective? Get ready?
Graphing sequences.
Graphing sequence. So we've already learned about sequences. Today we're going to learn how to turn a list of numbers into a graph so that we can study their shapes and their trends and see what they're doing. Take this sequence, 5, 10, 15, 20. I want you to think of it. It's just a list of numbers, but we talked about first term, second term, third term, fourth term. Couldn't the term number be part of an ordered pair? In other words, the first goes with 5, second term is 10, third. So if I change that into, think of it like a table. This is the x value and this is the y value, and we've just flipped it into this table. First term is 5, second term is 10, third term is 15. Let's graph it. First term is 1, 2, 3, 4, 5. So I'm going to label that 5, so when Mrs. Boone's correcting yours, I can say, oh yeah, they did put it at 5. Second term is 10, 6, 7, 8, 9, 10. I'm going to label that 10. And third is 15, 11, 12, 13, 14, 15. And fourth term is going to be a little bit off. But I can see the shape of my sequence. Is it still good, Alex? I just noticed you bumped it. So my shape, if I took a straight object, it is linear, and it looks like it goes through the origin. Let's find out if it does go through the origin. Let's establish a rule here. What is the rule? Does it have a constant multiplier, and what is the multiplier? Get ready? 5. We call it a constant of proportionality, or constant of variation. We times 5 on everyone. So I could say my output is equal to my input times by 5, and I'd put that in front. So a sub n equals 5 times n. So meaning if I had a 0th term, 0 times 5 would still be 0. So yes, indeed, it does go through the origin. So I'd say it does have a direct variation relationship. The next example is a cool sequence that we haven't seen before. But look at how these numbers start at the value 1, and then it goes 1/2, 1/3, 1/4. So if I did the same thing, first term, second term, third term, fourth term, fifth term, look at the relationship. Second term is a half, third term a third, fourth term a fourth, fifth term a fifth. What's my sixth term value? Get ready?
1/6.
Good. The sixth term value is 1/6. So we're going to just put them all in here. 1 is 1, 2 is 1/2, 3 is 1/3, 4 is 1/4, 5 is 1/5. Some of you advanced thinkers are already thinking, it's 1 over the term number. We're not going to worry about the equation for right now. Let's graph it. First term is 1, so I could go here. 2 is 1/2, 3 is 1/3, 4 is 1/4, 5 is 1/5, a 6th, a 7th, an 8th, a 9th. It's going to get smaller and smaller and smaller. And I can see it's kind of curving down smaller, but there's another way to do this graph that I like better, and that is changing the scale. All that was wasted room. I didn't have any graph or any data there. I didn't even need that much of the graph. In fact, since it's 1 and less, couldn't I call this 1? This is 0.9, 0.8, 0.7, 0.6, 0.5, or 1/2, 0.4, 0.3, 0.2, 0.1. So my first term was 1. Now I'm using more of my graph. I can see a really clear picture here because there's 1/2. 3 is 1/3. Isn't 1/3 a slight bit bigger than 0.3? It's a little bit bigger. So right above. Fourth is 1/4. 1/4 is the same as 0.25, which would be smack right there in the middle. A fifth would be 1/5, which is 0.2. And I could see that shape's going to go down. All you need to do for these is the first 4 numbers. We did 5. Okay? Question for an advanced thinker. What's my 0th term? Don't blurt it out. I'm just kind of curious what happens up here. Because I can see it's getting higher, but what value could it be? Spencer?
Well, it's not a number because 1 over 0.
But how did you know it was 1 over 0?
1 over the number of that 1 over the term number.
Okay, so you're saying it's 1 over the term number, so this one is 1 over 1. It goes 5, 4, 3, 2, 1, 0. 1, 1, 1, 1, 1, 1, 1. It has to be 1 over 0. Do we know how many zeros fit into 1?
It's undefined.
It's undefined, but wait for me to call on you, Jacob. It's undefined. You can't measure how many zeros fit in one. So in high school, you're going to learn that it's called an asymptote. Asymptote, A-S-Y-M-P-T-O-T-E, asymptote. And it'll have a dotted line, but it's not in this course. It's just a little sneak peek for you. Graph the first 3 terms of this sequence. Well, they didn't give us the numbers, but they told us the equations, so we're going to figure out what the numbers are. Just like in the bell ringer today when we said find a sub 1, and we said 3 to the 1. A sub 2 is 3 to the 2. A sub 3 would be 3 to the 3. So let's find those values. My first term, second, and third. First term is what? Get ready?
3.
So let's make sure everyone's, I'll give you more think time. Our second term, what is the value? Get ready?
9.
9. Our third term, remember it's an exponent, be careful. 3 to the 3rd power. Get ready?
27.
Perfect. Well, gosh, I don't even have a 27 on my graph. Change your scale. In fact, I'd probably go, what if we counted by 3s and did 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. What I usually do is, whatever my highest number is, I just find one of these tick marks and call it that. And then I figure out, well then, what's the rest going to be? How do I scale that down? I'll start with sometimes a halfway mark. This one doesn't have half because it's an odd number. But. Okay, let's graph. 1 is 3, 2 is 9, 3 is 27. And then could you guess 4 is going to be 81? Way up there. So clear up there. Is it linear?
No.
No. Does it go through the origin?
Yes. No.
Well,
Because 3 to 0 power is still 1.
okay, we're thinking. The 0th term, that's kind of a nerdy way to say it. That's how you say it. The 0th term is 3 to the 0 power. What is 3 to the 0? Think. Get ready? 1. So it looks like it does, but it doesn't. It goes through right there at 1. Notice, I didn't connect. I was tempted to, but I didn't connect my points. Why? Jacob?
Because, like in another graphing lesson, you told us that when you're doing sequences, you can't, it's a step thing.
It's only integers. Meaning there isn't like a 1.1 term. There isn't a 1/3 term. There's no data between, so there's nothing between here. There's nothing between. So you're only graphing integers. So on the test, if you connect your points, you'll get it marked wrong. You get points off. So only graph the points, just leave it alone. Okay? On your practice set, I would like you to be very strategic. If this is your whiteboard, I would like your graph to look like that. All of these sequences are in the first quadrant because they're all positive values. I'd like you to do 1, 2, 3, and 4. Make them all equally spaced. And then decide what your scale is. Is your biggest term 100? If that's the case, where's 50?
Yeah.
Okay, so then that'd make 25 right here. So adjust your scale. For example, if your highest term is 1, then that would make 0.5 right there. So then you have to adjust your scale. So you just decide what your highest one is, but please use a lot of your board to make your graph very neat and readable. You can fit your table over here on the right side because there won't be very many points up here. Any questions about today's lesson? Kind of make sense? Yeah. Well, sense? Yeah, not too bad. We're on page 100. Take a stand up break.
Whoa, that is a lot.